Hi there, my name is Alexander Martyushov, and today I want to talk about evolutionary architecture and, in particular, about architectural testing. And let me give a bit of a context in the beginning. Um, whenever you have a problem and you decide to solve this problem by software application, you should think about architecture of this application to have an architecture which is stable for many kinds of changes. So usually I split these changes into two main categories. So the first one is the technology-driven changes. As an example, I remember how Docker has changed I would say, the industry and the particular teams and approaches in the teams. And the second category is business business requirements driven changes. These are all the feature requests, fixes of existing features, all this old known business requirement implementation. And we all know that everything is changing all the time. But from the other hand, the stability of architecture should be stable from several points of view, such as performance. It means that whenever the application is changing, there should be no performance degradation, at least without a strong reasoning. Same for security, scalability, legality, and architects in the team who are responsible for doing long-term planning of the architecture of the application, how it should look like. They should balance between two facts. So the first one is, of course, the long-term planning, the long-term matter, and the second one is constant changes which are happening. And it means that there should be a concept and the practices of architectural governance. And I would highlight this keyword governance here. As an example, let's consider the abstract company where people once sat down and created the ideal documentation or policies about the architecture of their product. But who can give a guarantee that these agreements will be followed in 1 year or in 2 years? I would say most likely the architecture will degrade over the time because of many reasons. For example, discipline and new people are joining the team, and so on and so on. Architecture is degrading, and without proper governing, it will degrade. And I would say that architectural fitness functions are the answer in this case. So the fitness function is just any kind of abstract function which checks that particular agreement about the architecture is still valid and is still followed. And even more, in an ideal case, the fitness function is a definition of this agreement about architecture, and at the same time it is a verification of this agreement. And after introducing of such a concept of fitness function, let's then formalize what is evolutionary architecture in the end. So evolutionary architecture is an architecture which supports guided and incremental change. It means that how each change reflects to architectural agreements, and this change may happen across multiple dimensions. And the fitness function helped to provide these capabilities of the architecture. And particularly today, let's consider the tool which helps to implement exact kind of fitness functions. And first of all, let's agree and make sure that fitness function is not a new framework. This is not a framework. These functions use tools which are in the market for many years. These are different kind of monitors, unit testing frameworks, metrics, health engineering, and so on. All these things can be used to implement fitness functions. And let's consider one exact tool which can help to implement particular fitness functions. This tool is called ArchUnit. This is a library which helps to check dependencies between packages and classes, also check any agreements regarding how do you split the code into layers, to check any cyclic dependencies. So it works. So this library works by analyzing bytecode of your classes, also using reflection, and the library provides quite convenient Fluent API, which you can use to express your agreements regarding the architecture, and these tests can be executed by JUnit 4, 5, by testng. So it means that these tests are quite fast and cheap to implement, and they can be executed in each merge request or pull request, and it means that each incremental change of the product will be verified against the set of these like fitness functions, also known as architectural agreements. So I will show you currently a couple of examples. I have taken them from the official ArchUnit repository, so you can find more. So let's go through really simple examples to have a first impression about the tool. For example, this test will check that particular classes in the package which are annotated by a certain annotation should have a particular name. So so this test will make sure that the naming policies will be followed. Also, coding rules, for example, that the logger of the class should be private, static, final. Package structure, so that particular classes with a particular name should reside in a particular package, right? The structuring of the packages. Also, this test will check that you follow the agreements regarding the layers. So how can you access classes from each package by classes from another package? Pretty much the same can be achieved within such an API where you just define the alias for the layer, for example, layer of controllers, and you define the packages where these controllers are living, and like the service layer, persistent layer, and you then define the communication between these layers, so who can access whom, and so on. And also, I am as a fan of PlantUML. I like to draw such kind of diagrams to express relations between objects, so between packages, and ArchUnit support such kind of diagrams. There is a exact requirements to the diagram, but you can have from one hand the visual representation of the agreement, and at the same time you can feed this diagram to the ArchUnit and say that I want my code to follow this diagram. So these are basically it. Really, the API. So we are using ArchUnit in our project, and we're we're actually happy. The API is really expressive, so you can extend and provide and implement your own, maybe a bit more trickier conditions and verifications. But in the end, the test which checks particular agreement looks like a kind of a documentation. So you read it like a book, like a sentence. And we're quite happy using this tool, and it helps us a lot. And we're constantly adding and adding tests to like phrase our decisions, which we make on the any kind of tech lead meetings. So what else? You can find a lot of more examples. Let me on GitHub repository of ArchUnit. I hope this quick introduction of the tool is useful, and it just opens a window for you, and you can experiment with it and really help your product to govern the architecture of the product. So thanks a lot for your time, for listening. If you have any suggestions, any ideas, feel free to comment. We'll be glad to have a conversation with you about this topic. I'm really into the topic of architecture. Yeah. So thanks a lot and good luck.